We're at 28 right now. So some of the questions coming in right now. We have a limit of 100 participants. And we have this is going to be a hands-on webinar. So we will be using Jupyter on DesignSafe. So you will need to log into your DesignSafe accounts. So we have approximately five to 10 texters on our chat window right now. They'll be answering questions. And 2 more minutes and we'll get ourselves going. Make sure we have everybody logged in. All right, 1 more minute and we'll get ourselves going. All right. So before we get ourselves going here, hope everyone can hear me okay. One more time, we have a chat window in Zoom that you can access to ask any questions. We have about 5 or 10 taxers, people here working at TAC, who understand the system very well and can answer any questions that may come up. Once again, if you please leave your microphones muted, that way everyone can hear the webinar and there's a little feedback going through. Couple things before we get started is you will be using your DesignSafe accounts. We will be using DesignSafe. This is going to be very much a hands-on lab. I will be giving you some instructions and we'll be going into Jupyter and we'll be typing those instructions in. Before we get started though, if you can, please log into your DesignSafe accounts now and we'll go ahead and fire up our Jupyter notebooks so they'll be ready when we're ready to use them. So to do that, go to DesignSafe-CI.org, log into your account. Under the Research Workbench, there is the workspace. You may click on that. In the application tray, there is Jupyter. Go ahead and select Jupyter from the application tray, and it should be coming up with a link here. Now, once you see the DesignSafe-CI Jupyter Notebook, go ahead and launch that. I'm already logged into mine, but it will ask you to log in again. In fact, I'm going to go and log out so you'll see the same exact screen. It says log in, so we're going to go ahead and click on that. And there will be a start my server. So we'll go to my server, and we'll let it go ahead and launch in. Once we're inside there, go to the my data directory, and we're just going to leave that sitting there for a little bit. If things are running a bit slow for you on Jupyter, this is a big test for us to see if we have a number of users, how many users we can actually push. And show the desktop. All right. So if everybody can see everything okay, we're going to get ourselves started then. All right, so this is for our agenda for the day. We do have a 2-hour time slot set aside. So about an hour into this, we will probably take a quick 15-minute break, and then we'll continue on. All right, so things we're going to do, we're going to introduce the Jupyter Notebook. We're going to do an introduction to programming using Python. We'll show you some really cool things you can do with Python in Matplotlib, which allows you to do some graphics work. And then we'll see how all those things come together. Scott Brandenburg, who is an associate professor at UCLA, will be joining us in the second half of the hour, or in the second hour, to talk about a notebook that he has put together that is directly related with DesignSafe and the natural hazards community. And that way you can actually get a good feel for what this technology can do for you and how you can use this technology in your own workflows. All right, so DesignSafe has a vision. We want this to be your area to come and do your end-to-end research. That is, conceive of the idea, write your program, load your data, run your data, analyze your data, and then publish your data. So to do that, the first thing we decided to do was give you a programming environment. The programming environment that we chose is the Jupyter Notebook. The Jupyter Notebook has a lot of benefits. So essentially, what is it? It's a web-based interactive computing tool, all right? Essentially what it is, it's a programming tool online that allows you to write some code, put some good comments into your code, format it in such a way that it becomes easy to read, easy to follow, and then be able to share that notebook and share data with other people. So here, essentially, it's a big communication tool is what we're using it for, to be able to communicate your program, your code, your data with other people. All right, so how do these notebooks work? So an open notebook has essentially, just this big definition, has exactly one interactive session connected to a kernel, which executes code sent by user, communicate back results. Really what that's trying to say is that it is an interface to a kernel. So behind the scenes, there is a kernel, essentially the programming language that we're going to be using to communicate with. Anytime we execute code, we write code into a cell. That cell goes into the kernel. It executes. It runs its output. And the output is displayed back into our notebook. That way, everything is concise and sitting in this notebook. So the way things are structured, we're going to be looking at this real quick, but having a little bit of talk about it first. So notebooks are structured with code cells and markdown cells, all right? A code cell is exactly that. That's where you put in your code. And what coding language you use depends on what kernel you're connecting to, all right? So you type your code in, and when you're ready to run, you can either use the toolbar and run that cell, or you can click Shift-Enter and run the whole, run that cell with the keyboard shortcut. Now, markdown cells is really where the beauty of Jupyter is, or a Jupyter Notebook is. Anybody who's a coder can read code, and if we comment our code well enough, anybody else could understand what's going on. What a markdown cell does is it allows us to mark up our program to give better descriptions of what each cell of program does. Now, mind you, I use the word cell. I did not use the word code or statement, because we can group as many statements together as we need to per cell. We usually kind of organize it with kind of a logical format. Things that go together, we go ahead and organize in. And the markdown cells is really what makes the notebook pop out. All right, so a little bit about the markdown cells. You can add headings. So we can use the hashtag to put headings inside there. We can double the hashtags to put subheadings inside. We can add lists. You know, we can put a first ordered list. We can add items in there. We can order them however we wish to, just by taking our standard formats for marking. And the beauty of it is we can also put actual HTML. Since this is a markdown language, this is actually a superset of HTML. It actually takes pure HTML inside there. So inside of a markup cell, we can actually put some HTML in there. And we can also use latex. So this is where it comes into play at if there's equations you're trying to solve, equations that you're trying to display. You just put those within inside the $ tags, and the latex code will go through. All right, so the first thing first, we're going to go ahead and launch up a notebook. So I'm going to go here, and I'm going to click on New. Now, this gives us a bunch of different items we can do, and we can talk about some of these later. There's text files, there's folders, there's a terminal window that we can access in the background, and then these are our notebooks, and these are the kernels that run behind it: Bash, Python 2, Python 3, or R. For our examples today, we're going to be using Python 2. So the first thing that it shows us is a code cell. We can also insert a markup cell. Oops, I lost it. There we go. So you can see what we kind of have here going through our menus. We have our file where we can select a new notebook, change our kernel if we need to. We can open an existing notebook. We can make copies. We can rename. We can save and checkpoint. This is actually very important. As you rebuild these notebooks out, occasionally when you want to make a save and a checkpoint, checkpoint is very, very similar to how it is in a video game. You save this location, and then you maybe revert back to that location in the future. Then, of course, you can also download your notebook. So you can download it as a notebook. You can download it as Python code, HTML, simple markdown, or PDF by latex. All right, so the first thing we're going to do is we're going to go ahead and do a little bit of markdown. So I'm going to go and say, all right, select markdown cell. Now, if you notice, some things disappeared. So when we're in a code cell, we actually have this word in, meaning input. I'm going to change that to a markdown, and we're just going to put down a little heading to say, this is my first notebook. And if I hit Shift Enter, it'll go ahead and put that inside there for us. Now, we're going to do a little bit of code. Actually, it didn't quite fit that the way I wanted it to. There we go. There we go. Need a space after the hash to be able to get that heading in there. Now, that will stay. Shift Enter will go ahead and set it up. All right. We can also, like I said, inside of our cells, we can also put HTML inside there if we wish to go ahead and make things a little fancier. But and of course, you can put latex in there the same way. So the first thing we're going to do is we're going to see how we're going to organize our notebooks. All right. So typically, you're going to be working on a computational problem in pieces. All right. So the best way of organizing these notebooks is to create these cells into pieces. And basically, whatever is most convenient for you. Some things you realize that if you do some definitions in a single cell, those definitions have to be ran before other definitions, and so those cells may need to be ran first. The way I kind of look at it as, the way I really look at what Jupyter Notebooks are is, so my father, when he was working on his PhD, he was working in a wind tunnel and had to run experiments. So what he was telling me, he had to keep, after going through his stuff, he kept all these logbooks of all of his experiments, exactly what the settings were, what the parameters were, what object was currently in the wind tunnel, how long it was in there for, things like this. And everything is detailed inside this notebook. So essentially, he could hand that notebook off to somebody else, and then somebody else could replicate his work. That's the exact same thing that we're doing with Jupyter. The idea is this is essentially just like a traditional paper lab notebook. So you can kind of think of that as a way of guiding you how to keep your notebook organized, where the data should go, how things should feed into one another. So, and as far as how the organization goes, that's really 100% up to you. All right, the next thing I want to show you is just some shortcuts that we'll be using throughout here. Shift Enter to run a cell. That's probably the most important shortcut there is, or else you just be going back to the toolbar, which occasionally I will do. Control there's Control Enter that runs a cell in place, Alt Enter that runs a cell and inserts a new one below it, and then Escape and Enter, which changes you between Command mode and Edit mode. All right, so this is essentially our introduction to Jupyter Notebook. It's kind of short and sweet, but it really doesn't do anything until we actually put some programming into play. So for this webinar, we will be learning how to program in Python. So the first thing we're going to be doing is we're going to type our hello world program in. We're going to talk a little bit about data types and variables, our arithmetic operations, relational operations, input, output, some control flow, and then jump into some more different data types that really make Python really flash. And then we're going to play with Matplotlib. Matplotlib is probably the coolest thing that we can do with the Jupyter Notebook. And before we get started, I am going to stress that the magic number is 4. And we will talk about why the magic number is 4 and exactly what that means. But for now, the magic number is 4. All right. So if everybody's caught up with us, we're going to go ahead and do our little hello world program. What I actually like about hello world programs is this is probably the only program you'll ever write that you will never have to debug. So we type print hello world, exclamation mark, and then we hit Shift Enter. All right, I'm going to give it a little bit of time for people to type in there. And if you see what happens, it ran our code. This is the output for the code. And then it gave us another code cell. And once again, this code cell, we can change things around. If we'd rather this to be a markdown, we can. And then we can add another heading to it. So 2 of them this time, and a space saying, all right, I just ran my first Python code. And I Shift Enter again. And if you notice, it's a slightly smaller font. And now we can continue on with our Python programs. So the next thing I want to look at is we can do other things. We can print numbers. So I can hit print 5. I can, of course, since this is a notebook and cells don't have to be just one line of code, they could be multi-lines of code. So I can do this. I can, of course, print 1 + 1 as well. And we can hit Shift Enter, and it'll run those for me as well. And we get our output. Now, we can do, if this is our entire line of computation, where we have to print lines and print individual statements, our programs are going to be rather huge. So the first thing we do, really, I mean, there's 4 steps to programming, really. There is input, output, there's variables, there's control, and there's control flow, and then there's loops. So those are basically the 4 categories that we're going to be covering in Python. So the first thing we're going to have to look at is, hey, we're printing all this stuff. We need to capture it somewhere. So we're going to be saving those things inside of variables, and then be able to use those variables later. And of course, since this is a Python notebook, and this is a Jupyter notebook, and it's essentially all one giant code, we're going to be going back and forth through variables that we set at the beginning of our program and the variables we set in the middle of the program and be able to recall them. Okay, so how do our variables work? So we essentially just set a name. So if I say my variable 1, we'll just go here to the next cell here. And we can say things like 5 = 5, 1 = 1. And if I wanted to print that, I'm just going to go ahead and shift. If I hit Shift Enter here, since there's no output, since there's no print statement, it's just some things being loaded, it's just going to go ahead and give me the next cell code block. So here I can just say print 5. I can hit Shift Enter, tells me what 5 was. I can hit type print 1. And it'll tell me what the 1 was. I can do other little things like print 5 + 1 and Shift Enter that. We can go a little bit more interesting if you wanted to. 1 + 1 and know, we can keep on going with this. And of course, those were one of the data types. The other data type we have is a string. So I was going to show you, say we put our hello world into a string now. And I was going to do a little bit of print. Oops. I will warn you guys, I am a C programmer at heart. So you're going to see me type printf quite a bit. You're also going to see me put semicolons at the edges of each statement. And so you're going to have to excuse me on those. All right. So I can type print message. And hit shift enter there. And it prints out what the message was with hello world. So now we're essentially building an entire block of all these variables inside of our notebook. And we can go back to any one of those from our previous one. So I can hit print 1 again, or I can hit print 1. I can say, print 5. I can reset the value of 5, my parameter 5. I can set that equal to, 6. And then print 5 again. And we can make life really confusing for us. All right. So now that we have our variables setting up and we can build these variables in and we can start combining things together, we can actually start a little bit of programming. And with that, we can start doing a little bit more into our data types. And there's things I actually kind of want to show you. So there's 3 basic data types in Python. There is integers, floating points, and strings. Really 3 basic data types in any programming language. But the interesting part of Python is if I have an integer value, so I'm going to say integer val, I'm going to set that equal to, with the example of 100. And if I print int val. Now notice a couple things here. Float val equals, say, 100.1. And print float val 100.1. And of course, string val. Oops. Notice what's going on here. And people who actually program in other languages, this is where you start getting a little, wow, that's just blows my mind away. String val equals hello universe. I didn't declare any type, I never gave a data value or data type to any of those parameters, variables I just used. I just put them in there, gave them a value, and let it go. Python is actually smart enough to understand, hey, you just used a string, you just used an integer, you just used a float, and it'll automatically data type all those for me, and it'll automatically give me the correct data type inside of memory allocated for it as well. So unlike C or unlike Fortran, we don't actually have to go in there and type out what variables they are. Python will capture that for us. But then that leads us to some issues. All right. So variables have a type, even though it's implicitly done. It's got a type, and we can check that type of variable anytime we want to. All we use is a type function. So if I say type string val. Val, and hit, oh, I need to print that out so I get the return type. We'll say, oh, that's a type string. If I ask for a print type, what's my int val? Go and say, hey, that's type integer, which is all fine and great. But what comes into play is now we have all these different types of variables that we never actually declared what these variables are. So if we ever need to mix and match variables around, for example, if I say, all right, I want to print out string val plus int val, and let's say I'm not as clever with my variable names, and I just put those in as strings and say, okay, go for it. Hey, something happened. It's not going to be able to do that for me. So you need to kind of keep track of what your variable types are. If you don't wish to keep track of what your variable types are, well, then you need to use the type command to do that for you. So you're not going to be overstepping on other variable types. Something else I should point out, which is this is a great place to point it out, is your errors are also going to be shown in these output cells as well. So if you had an issue with your code, it's going to throw that out. And if you wanted to, you can always just go back in. If you notice a couple things here, this is in command mode. So if I type my keyboard, it's actually not doing anything except changing that command type, which I actually just did a shortcut for. I'm going to re-execute that. And oh, I see. It went back to raw. Go back to code there. And I'm just going to print that, fix that out for me. Type string val. So, anyways, if you needed to convert something from one variable type to another variable type, what you can do is we have a couple little keywords that they gave us that we can essentially use to do our conversions. What we can do is we can use the str that will convert a integer or a float to a string for us. So now if I did want to do that print statement before, if I wanted to print string val plus str, so I'm going to convert that to a string and call it int val. And now it's going to say, hey, hello universe 100, concatenate the two together for me. And of course, we can also convert strings to an integer, strings to a float, and vice versa, things around. But here's the thing you kind of have to watch out for, is you really want to only convert data that actually makes sense to convert. For example, if I were to say print integer of my string value, and I want to add that to my string, integer string value to integer val. Once again, it's going to give me an error because if you actually, the errors in Python are really good. Invalid literal for integer with base 10 for hello universe. Essentially what it's saying is, hey, I don't know what hello universe is in base 10. So it gives us an error. So of course we can always go back to this cell. We can go ahead and edit it and say, oh, that's not what I meant. I actually did mean to add the string value to the string portion, str, of the integer value, and rerun that. By the way, if you ever forget what your the keyboard shortcuts are, this is your run cell. This is basically cancel your statement if you want to break if something's just taking too long to run. And this is used just to navigate up or down through your cells. Okay, so now we can essentially create variable types. We can load our variables up with some kind of data. We can do some calculations if we wanted to, and we can convert. So let's move on. This next thing we really kind of want to do is do some arithmetic operations. All right. So we have addition. Plus is addition, minus is subtraction, slash is your division. Modular function, essentially it gives you what the remainder is when you divide two numbers together. Multiplication, floor division, and raised to the power. So most people with other programming language experience will recognize these. This one is a killer for me because, like I said, I'm a C programmer. So I will go in there and accidentally use // when I meant to use for a comment, when I meant to use a hashtag which will comment for us in code. All right, with those arithmetic operations, we're going to do just some experiments right now, and we're going to see what happens here. So I'm going to go ahead and say print 5 divided by 2. We're going to go, that gave us 2, so something to look at. The Python looked at that line, and it said, all right, you're taking an integer, and you're dividing by an integer, So your result will always be an integer. And this is something I always actually stress in my classes as well, that an integer divided by an integer is an integer. It will drop that fraction part every time. So if we want to actually if we want to actually go ahead and get a floating point out of there, we have to take a floating point divided by an integer. Easiest way, of course, 5.0 divided by 2. Shift enter, 2.5. We can also do our convert that we learned last time. Divide by 2. Also giving us the same answer. We can also concat strings, as we saw. Notice what this does is it actually just concats the two strings together. There's no space, no nothing. It just takes those two strings and concatenates them. Also, what we saw before is we cannot, I kind of like this on one example. We cannot do something like that. It cannot concatenate a string and an int. If we want to do that, we have to convert one of them to a string. So if I wanted to fix that, I would just say str, convert it back to a string, and then execute it. That works just fine. And this example then gives us some weird things too. If I say number times 5, kind of expect it not to work either, but all that does is it repeats the word number 5 times. Actually, technically, it repeated the string 5 times. And then, of course, as we all should expect from our programming languages, the order of operations does remain into effect. Okay, so far so good. We are able to use Jupyter. We're able to kind of put some basic stuff together, put some basic variables in there. But one of the things that we have to think about is whenever we actually write programs, most right now, technically, with a big giant machine like we have here at TAC, Stampede, our supercomputer, you should never ever read anything from the keyboard. But for a program like this that we're using Jupyter for, you may have a situation where you do need to read in some values from the keyboard. And the way Jupyter is set up, you might think, well, can I do when I'm running a console app and I write my little code and I say input and it gives me a prompt and I go ahead and input in whatever data I need to hit and hit enter. How is Jupyter going to do it? Because this interface is a little different. Well, for that, let's experiment. So let's set up a generic variable var equals the command in Python to enter a number is input. So I'm going to input, please enter a number. And we will see what Jupyter does with that. I'm going to hit Shift Enter. Now it's kind of cool. Jupyter gives us a little text box. So it automatically recognizes what's going on. It automatically goes into its into its depths and says, hey, you need a text box for this. So it goes ahead and gives me one. So, all right, please enter a number, 42. And it kind of keeps it in there. Now, of course, it's inside memory of var. So if I want to repeat what var is, and we're going to look at this here in a little bit. If I go ahead and now print var, it gives me that number 42 back. So now we have a nice little way of inputting numbers into our program when we need to. And of course, we can do the same with strings. So I'm going to say var2 equals input. Please enter your name. Now, I'm going to go ahead and hit Charlie. All right, it failed on me, gave me another error saying, hey, this isn't what I was expecting you to put. Essentially what it says, the name Charlie is not defined. All right, so let's think about what's going on here and why we got this error. So essentially we're saying, all right, var2 is equal to input something from the keyboard. Now, I want to enter a string. So the way that Python likes strings and the way most programming languages like strings is that you have to put those inside of quotes. So if I were to rerun this again, and I put my name inside the quotes, and hit enter, it liked it just fine. Now, there's something else that's kind of neat. So technically speaking is it said that was undefined. So I'm curious to know, what would it do if I say this is equal to string val? It didn't like it here. Oh, string val is not defined. Did I call that? What do you call it, string val? Huh. Didn't like that. All right. So for our quotes, you have to remember that if we're using strings, we're going to have to be putting them inside of names. And I know there's a way you can be able to pull that that string back, but it's escaping me right now. All right. So we will enter that. We can enter in strings using quotes around that, or else your program is going to crash. So if there's ever any time you need a string in there, like a label of some sort, and you need to put that in there, you have to be able to tell the person that, hey, you need to put those in quotes. Okay. All right. So now we're able to output stuff back out. So I can print var2. You know, I can print my var1. And get 42. Now, if I needed to make things a little prettier, what we kind of have to do is we kind of have to go in there and say, all right, we're going to have some formatted output. So to set up formatted output is very similar to other programming languages like C, for example. It's basically what you're saying is I'm going to say print, and we can say, if I just wanted to go ahead and do a straight print, I say my name is, oops. My name is, I'll say, all right, I need a string. So I'm going to say %s. And I'm going to tell it that, hey, we're going to have some output coming to you. Go through there and replace it with whatever variable I'm going to be putting here, which I'm going to be putting var2 inside there. And it says, my name is Charlie Day. Now, of course, if I wanted to, I can also change this around as, I could say %s. Is my name, and the answer to life, the universe, and everything is %d. And now I can say %var2, var1, or just var. Oops. I missed that. Oops, I think I forgot to put the, oh, I forgot to put the other person's name in front of there. My bad. Yeah, I'm having a bad time typing today. Yeah, I'm having a really bad time typing today. All right. Let's just split it up into different lines. I'm going to say %. That way I can at least see it a little bit better. And it makes it organized too, which is the beauty of that. And print. And the answer to life, the universe, and everything is %d. And that's going to be %var. There we go. Splitting it up worked a lot better. I was losing where I was. All right. And then, of course, we can make things a little bit easier to play with as well. We can put in a \n for a new line, or \t to insert a tab if we want to space things out a little bit better. And it actually helps with our output and our format. Okay, so now we're kind of played around. We were able to input things from the keyboard. We're able to output things back to our output cells. But that doesn't do us much good. especially if we're in the middle of computing a big number set and we don't want to see that up to our screen. We need to actually save that into a file. So the next thing we have to do is be able to figure out how do we write files. Now, the next thing we're going to do, so we're going to be writing to a file. So what we're going to do is we're going to say, all right, I'm going to need to do a couple things first. I need to open a file and say, hey, I want to write to it, and then be able to put in the variables I need to write. So I'm going to go ahead and do this. We'll say my file, and I'm going to say open. So I'm going to say, all right, let's open a new file. We give it a file name. I'm going to call this my output. And it's just going to be straight text. I'm going to put .txt next to it. And we're going to open that with W. And we'll go through what the other variables can be for writing a file. And we're just going to start writing stuff to it. So we can go through the example, but we already have a bunch of variables set. Excuse me. And we are going to go ahead and just write those in. So I'm going to say my file. And we're going to say .write to be able to what it is you want to write out, and then what variable do you want to write out. So I'm going to write the variable var. Okay, there's my semicolon again. And now I'm going to say my file .write. And I'm going to this time write out the var, I think it was var2. And now, just because I need one more number in there, I'm going to say var, I think it's float val is what I had up there. So here, if you notice, since up in earlier in my notebook, I actually had float val, so I'm going to go ahead and recall that. And now the last thing I want to do is, you know what? No, we're going to do this. We'll say, all right, my file.write. My file, since everything is in there that we want it to be, we'll say my file.close. And we're going to close this thing out. And we're going to run this bit of code. And what didn't you like? I had var up here already with the value. We can print var 42. So, don't you think? Print var 2. It doesn't like my number in there. Oh, you know what? That's what I forgot to do. So this is actually a very good example of what happens. So I'm trying to write stuff into a file stream. And the problem is that a file stream expects strings. That's what a file is. It's a text file. So it's going to want a bunch of strings in there. My example here is if I go here and say, all right, I got float val and that, I'm going to say, all right, what is type var? Shift enter. Well, type var is an int. All right, so I need to go back in here and I need to do a little bit of conversions. So I need to convert var to a string before I can actually write it out to my file. I need to do the same thing with my float var. It's going to be a string, so I can write that out to my file. And we're going to make everything should be set now. So shift enter, it should definitely run. And it did. All right, no errors, so it ran just fine. But there's no real output to it. So now comes the place where the data depot comes into play. So we just essentially wrote a little text file out there. So we're going to go back to DesignSafe now, and I have DesignSafe up in a different window. If you don't, we'll just open up a new tab, DesignSafe-CI.org. And we're going to go to our data depot and see, cross our fingers, that our file that we just wrote went out there. So here is a list of all my files that I have in my data depot. The file we just wrote according to our notebook, was called myoutput.txt. So myoutput.txt should be in here somewhere, but it's not there yet. Might be a little bit to get in there for it to re-index itself to be able to view your files. The other thing you can also do, it'll show up there. The other thing you can also do is go to the Jupyter Notebook main screen, and we can pull in a terminal window. The terminal window will, I'm going to go ahead and maximize this window for a little bit. Let's see what's going on. This won't let me. Okay. All right. So we can also just check here. I'm trying to get that screen bigger, and we'll refresh this real quick. And we'll see that our file did indeed get put out here of my output, which is right there. My output file 1. Should show up in the data depot here soon. Close that back out. And let's do a refresh here, see if it's in the data depot yet. And it should appear shortly. We'll check it again at the end. It might take a little bit for it to refresh through. Okay, let's go back to our notebook here. All right, so our file is basically there. So if we wanted to, we can open that file up. We know it's there because it's already showing up in our Jupyter Notebook tree, which means it's in our file system. And now, all right, so now that our file's out there, we kind of need to read from our file now. So these are the modes that we have when you're creating a file. So we're writing to it, we're going to use the W because we're opening it to write. If we want to open it up to read, we use the R, and that's what the default mode is. So if I just left that W off there, it would automatically want to open it up with the read, and then I would get an error. So if I just left this blank, Shift Enter, it's going to give me an error saying, hey, that file is not open for writing. You can't do that. So, all right, I'm not going to do that. So I need to write to it. Now, so R is for reading, W is for writing. Interesting to note also, if you are doing a W on there to write the files, just like other programming languages, it's going to overwrite the file if it already exists. If you just want to append data to an existing file, go ahead and use the A as your parameter, and then that will open your file up for writing. I'm sorry, for appending. So it'll take the existing file and just append the new data to the bottom of it. All right. So now that we have a file out there, we're going to try and read some information from that file. And I am now going to say, all right, we're going to reuse my file in, I call this a little bit different than what I have in the example, my file R. I'm going to now open up that file again and make sure I call it the same thing, myoutput.txt. It's a string, so it needs to be in quotes. And I'm going to open that for reading. If we wanted to, we don't actually have to put the R in there. If we leave it blank, remember, that's the default value. By the way, I should make a note that if anybody's actually trying to copy and paste from the slides, that may not work because the slide have, sometimes they have the smart tags in there and you're not going to be able to actually read those in. Python or Jupyter is going to get mad at you and it's going to be giving you an error that's not quite so easy to understand. So it's best just to type it back in that we have no formatting issues. So we're going to open up the file. We're going to read in the content from it. And my file _r.read. And I'm going to go ahead and print out the content. Print content. And after I'm all done, because I'm a nice guy, I'm going to close that file. It's always good etiquette to close the file after you open it. So let's run that little bit. And no syntax, you don't like something. R.read. What don't you like? My file r.open. Oh, I am tripping over myself. Content equals my file.read. That would help. And we're going to run this. And now I'm just going to print out the content. Now, if you remember correctly, in my original file, I had var2, var, and the float var. var2 was my name. The next one, which was var, was the number 42. And the last one was that float var from earlier in our notebook, which is a floating point number 100.1. So I printed all that stuff out, and you know what? It's kind of ugly. It's all one line. It doesn't make much sense to me. So what we're going to have to do is we can have to format our data a little bit. To do that, we're going to use our little tricks we learned before with our print statements, which was using the \n for a new line, \t for tabs, and whatnot. So we're going to go ahead and put those in there. My file. So I'm going to go ahead and redo this here. .write. And of course, we can actually do this in a new notebook if we want, or in a new cell block if we wanted to. And /n for a new line. Same thing over here. My file.write. /n again. And we'll just put those two inside there. And I'm going to rerun that code block. So now that code block has been reran, the file's been updated. I'm going to rerun this code block. Now, with those \n in there, the data is a little bit more easier to read. Unfortunately, it's still inside of this thing called content. So it's still inside of there. It's still that means all the data that we've just put in there is all in one variable called content. And that variable, of course, is type string. Print type content. It's type string. So we need to make some modifications to it, or else it's just going to be sitting inside there. So one thing we can do in Python is we can read it line per line, which is what I'm going to actually go ahead and tell it to do. We're going to redo our file read. So I'm actually just going to go ahead and copy this information in the cell and repaste that in. And now I'm going to say, all right, here's our file. Instead of just reading everything, I'm going to say read line. So I'm going to say this is going to be var, let's just go say var s for a string. Actually, you know what? I'm not going to use var s. I'm going to use var string. And I'm going to say my file.read line. Since we know we only have 3 things to read, I'm just going to go ahead and do this way. Var int equals my file read line, and var float equals my file r.read line. And we'll just print those each. Var string, var int, and var float. Make sure those are all called. And close my file out. And we're going to run that, Shift Enter, or of course you can go ahead and click on the toolbar if you like. And it's going to print everything out for me, Charlie, 42, and 100.1. And now those are in 3 different variables. Of course, each one of those are strings, so I would have to do a little bit of conversion. So I mean, we can just do print type var int, and we'll say, hey, it's a string. Well, I don't want it to be a string. Well, now we know that we can do our cute little conversions. So I can convert this. Remember what we said earlier? You only want to convert something if it makes sense to do the conversion. Here, it makes sense to do the conversion because it's reading in a number. And here, of course, we're going to convert it to a float. Now, Shift Enter there. Also, notice a couple other things happened. Now that these have been converted from a string to an integer and to a float, so now these are actual numbers, that carriage return disappeared. So now it's actually looking at those as numbers. So if I were to rerun this command, Now it's looking at that as an int, which is exactly kind of what we want. All right, let's continue on here, and we'll take a break in about 5-10 minutes. All right, something else we are looking at is we're going to try and make this a little easier to read. So a lot of people, me included, I'm not a huge fan of typing a lot. And unfortunately in programming, you do type a lot. So we're going to make this a little prettier. And to make it a little prettier, we're going to introduce the with command. All right, so what with command does, it allows you to take an object. This is essentially what we're doing here is we're creating this file object, and allows you to do multiple things with that one particular object without having to do a lot of extra work or extra typing. So what I'm going to do is I'm saying, all right, with, well, what am I going to do? With that open file, that output, my output.text, and I'm going to open that, of course, I'm going to open that in read mode. And I'm going to now say with something, I'm going to open that as F. All right? Now, Jupyter is very nice for us. It will go ahead and automatically space things out. Not all of it will ever do that. And if you actually do other Python code besides this, you will know that you will not automatically get that space. Well, that is where your magic number comes into play at. And what's the magic number? The magic number is 4. That means 4 spaces is what we use to bridge our code out. So now everything underneath that with statement that comes with 4 spaces is going to be used with that command. So I can now just do var string, and I can say, all right, f dot read line. Say var int equals, I convert to an integer again, f dot read line. I'm going to say var float equals float, and f dot read line. And if I wanted to, I can now go ahead and print with those variables out. I don't actually need to tab over those anymore. I can just say, all right, print var string, var int, and var float. And because I'm a nice guy, I'm going to close out that file. Actually, you know what? I am going to actually put that inside there. That way I can actually do an f.close. f.close. Now, shift enter. I didn't like something there. Oh, I can do that. It's basically telling me that, hey, your syntax is wrong in that. So now, and I didn't do it here either. All right, much better, and looks good again. Okay, so now we're essentially being able to write things to our files, and those are in our data depot, so we should be able to share those out, and we should be able to read those things out as well. All right, so now we got our basic programming structure down. You know, we can make some arithmetic. We can do some math problems. We can do some print statements. We can write files. We can read from files. You know, actually, we're doing very good progress. The next thing we need to do is being able to control when our program executes and what it executes. All right. The way I always think about this, looking at control flow, is these are your conditions. These are if statements. If it's sunny outside, I'm going to grab my sunglasses. If it is raining outside, I'm going to grab my umbrella. If there's a chance of rain, I may grab my umbrella. You know, little things like this. You know, if you're living in Austin, you're going to be taking your allergy pills. Same deal. All right. So what we're going to do now is we're going to see how these control flows work. How can we put conditions in there? How can we check for these conditions? And how do we step through that? And about 3 more minutes here, we're going to take a little break. The first thing we're going to teach or talk about is the if, else, elif command. So this essentially gives you, if a condition is true, does something. Else, do something else. The elif comes into play at is else if you want to add a secondary condition to it. So if it's raining, I'm gonna grab my jacket. Else, if it's sunny, I'm gonna grab my sunglasses. Else if it's neither, you can do something else. All right. And then any line following that if, elif, else block is automatically going to get executed. So it's not part of that entire condition statement. All right. And once again, that magic number, for those of you guys who ever do this inside of a text editor, that magic number is 4. So that's how you define where that block sits at. Okay. So let's do a cute little example just from what we've done previously. So make sure that I still have that var in there. Yeah, var still 42. And now if we wanted to add a little bit of commands to it, I could say if var greater than 10, so the statement follows this one, if var greater than 10, colon. Now it gives me my automatic 4 spaces. I can say print, you entered a number greater than 10. I can hit the back tab to go back how many I can then type else, print, you entered a number less than 10. Oops, I forgot my colon. Oh, I forgot my colon in the slides too. I'm sorry about that. There should be a colon here in the slides as well. So essentially your block is if condition, colon, the statement. And of course, these can be a broad range of statements, doesn't necessarily have to be one. Then the elif condition, colon, and then your block of statements, and then your else with a colon and your block of statements. And of course, what's interesting about it too is we can nest these. So you can take a Python block and you can have this big giant block of if-else statements. Honestly, I will tell you that is, as a programming instructor, I don't like seeing that when my students do it because it's very difficult to actually grade. But you know what? There is a need for it sometimes. So the need for it's there. It allows you to do it. So I'm going to go ahead and show you guys that yes, you can do it. You can put big giant if blocks in there and nest them as much as you need to. Okay, so we've now been here for about an hour. Let's go ahead and take a quick 10-minute break, or let's do a quick 5-minute break. Then we'll come back here. We will close out Python, and then we'll introduce you guys to Matplotlib. And then Scott Brandenberger will be joining us, and he will show us his example notebook. All right, so about 5 minutes, we will rejoin at about 10 after 2 Central Time. All right, thank you. All right, guys. So it is now 10 after 2. So let's reconvene and let's get through the rest of this. So for the next thing that we need is we're going to close Python out here real soon. We got loops to cover and lists. And then we're going to go into Matplotlib, which is basically everything that you can do that makes Python exciting, at least for me. Not much happens until you can actually see what things look like. All right, so the first thing we're going to do is we're going to look at loops. Now, loops essentially give you it can loop over items, it can loop through a range. And so first thing we're going to do is, well, we need to figure out how to create a range. So the first thing we can look at is this range command. What the range command does is it creates a range of numbers between a starting point and an ending point. Once again, you use our colon, and the magic number is 4, so I can't stress that enough. And then finally, there's my printf again. You type what it is you want your command to do. So I'm going to say, let's go with our example and do a %d, and then our %x, which is what our index is. So what essentially this says is, hey, we're going to have a range that's going to go from 0 to 3. X is going to iterate over that. So x is going to equal 0, then 1, 2, and then 3. And then we're going to go ahead and print out all those values. So starting with 0, once it hits that top of the range, it's gonna jump out, and so we go 0, 1, and then 2. So we can now, if we needed this thing to loop through multiple things and compute multiple things that we're going to be doing here with Matplotlib, we know how we can do a range through that. Now that's just one way of going through a loop. So sometimes you want to start from a particular value, you want to end at a particular value. The other thing is sometimes you want to do a loop while a certain condition is true. So while there's gas in my car, I'm going to keep driving. So once my gas is gone, so once gas equals false, I'm going to exit out and my car is going to stop. Same deal here. We can set up an index. In this case, I can say, you know what? I'm going to, oops, wrong window here. Say I equals 0, so we can start from a certain point if we wanted to. And I can say, hey, while I is less than 10, I'm going to go ahead and start my loop. So while I less than 10, that's my condition, colon. I'm just going to go ahead and print I. We'll be quick here. And then I need to advance I. So I'm going to say I equals I plus 1. And now this thing's going to keep looping until the value of I is over that value. I'm saying, hey, we're done looping. All right, and we're going to go ahead and run that bit there with a shift enter. Now, so I is going to start out at 0. It's going to loop through to 10, and it's going to go ahead and it's going to go ahead and come out of the loop, exit the loop, when our condition's been met, or when a condition is no longer true. Our condition is now false, it'll jump out of the loop. Okay, a couple other things. Now, this is really, I think, is what makes Python a beautiful language, is the concept called lists. A list is essentially a collection of stuff, and it doesn't have to be the same kind of stuff. It could be different variable types that you can mix and match. You can create this list. And the beauty of it is you can then iterate over that list. So I'm going to go ahead and actually I'm going to create just a couple examples of it so we can go on to our Matplotlib example. So I can say my list equals 1, 2, and say the number 3. All right. And then we can do some cool stuff with it. I can print out the entire list, 1, 2, and 3. I can print out a section of the list. So I can say my list 0 and the index of it. We can also do slicing. So I can say my list. I'm going to go ahead and update my list. I'm going to put a couple more things in there, 4 and 5. And we can do stuff like slicing. So I can say print my list, excuse me, my list of, let's say, 0 to 3. as it's only going to print out those other ones. We can also shift that up a little bit if we wanted to. And then we can also do random replaces. So let's say 1 to 3. It's only going to give me those two. And then, of course, we can do cool little stuff. We can do, since it's random access, random write, we can then replace certain items in the list. So my list sub 4, I can set that equal to 6 instead. And let's print out my list again. 3, 4, and 6, which is the last item that I replaced. I replaced 5 with the 6. So that is really what makes Python kind of fun, is these lists have a lot of, they have a lot of uses that can come into play, especially with scientific programming. All right, and then of course there's functions that are available for that do things to a list. Like you can say, hey, I can do length of my list. So tell me how many things are in there. I can also do cute little things like I can ask it questions, like say, hey, is 3 in my list? True. I could say, hey, is 1 in my list? Oops. False. And then of course you can loop over it there too. Say, for example, we can I can do a for loop over the items in my list. And just print X. So 1, 2, 3, 4, 6. So it's kind of cool. So it just takes my list out of there, gives me all the items, and iterates X through there, and X is then set to each value inside my list. And then of course we can also look at stuff. We can append stuff to your list. You can ask it questions about what positions some things are at. You can find the max or the min. It's actually kind of fun to do. All right, so that's really the basics of Python. Then you could put all these things together and you could create functions out of it, and you could play a little bit longer with it. And you could call your function, you could reuse it. But really, what we kind of really want to do now is we want to play with Matplotlib. Matplotlib is one of the things I find exciting about Python. It's essentially the graphics library for Python. There's a lot of cute little things available in there. There's a lot of cute tools that are easy to use, easy to manage, and really lets you build things from scratch and be able to visualize what it is you're working for. All right, so first things first, let's go ahead and do a Matplotlib, play with Matplotlib. I'm going to go ahead and save this existing notebook and call it Intro to Python. And then I'm going to go ahead and create a new notebook. So, okay. And to create a new notebook, just go to File, New Notebook, and we're going to have another Python 2 notebook. This will spawn it up. Kernel is starting. And as soon as we're ready to go, we're set. First thing we're going to do is we're going to say, hey, everything we're going to do in Python right now is going to be inline. So I'm going to say Matplotlib inline. So now it's just a way of telling it how you're going to interact with Matplotlib or the graphics. I'm telling it we're just going to look at it in a static sense. Next thing we need to do is we're going to import our libraries. So we're going to import the Matplotlib library. And what we're going to use is we're going to use the Python plot, the pyplot, and I'm going to call it as PLT. Easier to use in the future. And we're going to import in NumPy. NumPy is essentially the numerical libraries that we're going to use for Python. If you're going to be doing Python for any kind of scientific work, NumPy is essentially going to become your best friend. And we're going to go ahead and run those, Shift Enter. Everything's sitting inside there, all nice and going. Pardon me? Oh, how do you save a notebook? If you go to File, you can save and checkpoint. Everything you really kind of do will be saved as you go along. In fact, you will see a message occasionally that says, hey, checkpoint saved. But the best way to save it if you want to make a save, is go ahead and click Save Checkpoint. And it'll go ahead and give you a save there. Also, if you just go ahead and rename it and hit OK, it'll go ahead and create that notebook for you. Yeah, you can rename it was one way of saving it. As soon as we renamed it, it saved it. As soon as we do a checkpoint, it'll also save it. Then it'll auto-save throughout your experience as well. All right, so now that we have our libraries set up, we're now going to go ahead and do our quick little first step. We're just going to say, all right, X, I'm going to say NP, so I'm going to access my NumPy. I'm going to create a group of data using line space. I'm going to tell it where it goes from and what it's going to go to. And I'm going to say 2 times pi, np.pi, and how many values I want. I want 50. Now, I'm going to do a plt.plot. I need to give it an array, which is X, which is essentially what we just built a little bit ago with the np.linspace. And what are we going to graph? I'm going to graph np.sign of X. One more thing we have to do is a plt.show. Now, if I execute this code, it will create a sine curve for me. And now that was actually really easy to do. All we did, we fed it an array, and we fed it 2 arrays, X and Y, and we told it to go and graph. And with that, we can go ahead and do a lot more fun stuff too. For example, if I wanted to now plot 2 graphs, so I'm going to say X and np.sign X. I also wanted to graph on that same exact axis. I also want to graph X versus np, numpy.sign of 2X. Plot.show. And shift enter to run that. Now, that gives me 2 plots on the same exact axis. So we can actually now start doing a little bit more fun stuff with it. Let's go ahead and take these next 2 cells we have, which is plt.plot X, comma, np.sign of X. And we're going to do a little thing here, and we're going to describe exactly what we're going to be doing here in the next slide. But I'm going to essentially tell it, hey, make this with circles and make them all red. And I'm also going to say my other X, let's say we're going to do np.cosine this time. All right. And I'm going to say, hey, make those greens and make those with lines. And of course, we need to do a plot.show. Now, with just this little bit of lines, we now have 2 curves, one with little circles and one with little lines. So we have a little bit of differentiation and but easier to read. And this is why I kind of like Matplotlib. There's nothing really extravagant about it. It's just really simple little commands that can allow you to view whatever data it is you're viewing. Realize that these are just 2 arrays. So you can build these arrays using whatever functions you want to build your arrays with, whatever math functions or whatever you're calculating, wherever they're reading from. They could be sensor data that you're reading into an array, and just do some simple graphs. All right, so let's, to make things a little bit more interesting, here's a little tidbit on what these values are. So you have colors, blue, green, red, cyan, magenta, yellow, black, K, since B is taken by the blue already, and W for white. Solid line, dashed line, this is an underscore by the way, dotted line, dot and dashes. You can use markers, points, pixels, circles, squares, triangles. You can have a lot of fun with these plots. All right. Now, there could very well be a situation where you want to use multiple plots instead of just graphing them on the same set of axes. You want to actually graph those on 2 separate axes. So for that, Python, what Matplotlib has given us, is called a subplot. So we can do a subplot on our 2 graphs if you wanted to. Just do PLT. So what do we want to do? We want to create a subplot. Now, subplots you have to kind of think about what it is you want to do. So I want to break this thing into two separate rows. So I'm going to have one row to be my first subplot and another row to be my second subplot. So I'm going to say plot.subplot2. Which row am I looking at? How many rows do I want? I want 2 rows. All right. I'm going to look at one, and I'm going to look at active area. So active area is essentially, all right, I'm going to create 2 subplots. Things got to go inside one, things got to go inside the other. The active area is essentially telling you which things go into where. So active area 1 is what I'm going to mess with first. And that's going to be my sine curve. np.sine x. And let's just make that red. And I'm going to go ahead and plot my subplot for my second one. Is going to be the same one, 2 rows, one column, and this is going to be active area number 2. And inside of there, I'm going to plot x np.cosine x, if I can type properly. And we're going to make that guy green. And then do a plot.show. And now we have 2 plots using 2 different axes on the same graph. We have our sine curve, we have our cosine curve. And we can still make things a little bit more exciting if we wanted to. We could, Matplotlib, instead of just graphing with lines, we can also do a scatter plot. This is actually rather simple. This first thing is just, I'm going to introduce y np.sine x. Remember, x is an array, so what's kind of cool is y is also now going to be an array. It's going to be the sine function over that entire array of x. And I'm going to say plot.scatter. All I need to do is feed it 2 arrays, x and y. And we can do a plot.show. And now, there's a scatter plot for the sine curve. And a couple other little things we can do. This is actually a kind of a fun little example, and we'll see how this goes. X equals, I'm going to say np.random. So we have a random function in the NumPy. Random, I can type random.rand, and I'm going to say give me a number between 1 and 1,000. And then y is equal to also a random number, np.random.rand 1,000. We're going to do some other things. Let's do color. Let's have a random color as well, a random size, random. And you're going to need 1,000 of those as well. And make those times 50. Give it a little bit of distinction. Color. Random.rand. We're going to need 1,000 colors. All right. Now, if we want to plot these things out, we can do plot.scatter. And we're going to give it we're going to give it all 4 arrays, x, y, what I'm going to graph. I'm going to also say vary my size and give me some color, those other 2 arrays that I introduced. Just to make life easier to read, we're going to add something called a color bar, which it's going to automatically figure out what colors I've used and build a color bar on that for me. And then we're going to do a plot.show and see what we get. See if this works. So we got a bunch of random colors, random sizes in a random area with a color bar telling us what the values that we came back up with. And this one's actually a lot of fun as well. So now we can do a little scatter plots. What we really, and then if you wanted to, I was going to look at these 2 things that we added. We added the color bar, which gave us the color legend, and we added the color to our scatter plot that made things a little bit prettier for us. The other thing, Scott's going to come in here once at 2:30 Central Time, so I'm going to go ahead and wait for him to come through. But the other thing we can do is we can also do histograms. So if you wanted to, I can do a plot.histogram, and I can say x And how many bins do I want in my histogram? 50. And I can do a plot.show. Oops, if I typed that right. And so now it gave us a histogram on X. If we increase 50, it would increase the number of bins. And then the final thing that I'm actually going to let you guys look at yourself is if you go to our training guide under Python. So I want to give some time to Scott. If you go here to our where'd it go? If you go back to DesignSafe and we go to our Learning Center. Under our Learning Center, we have something called the training resource. In the training resource, we have things archived. So if you go to the archive, you'll see that we have a couple of class materials. Here are the slides we went through today. And here's a data file. So if you pull this data file down and rename it contour.dat and then upload it back through, you'll see some very interesting, it's a very cool way of doing some contour plots. Because of time-wise, I'm going to go ahead and skip over that, but I do want you guys to play with this and see what you can find. Because we can do a lot of really fun stuff with just as big matrix data, which is what the contour data is. It's a big matrix data that is sitting on there that we can pull up and attach colors to. But the last thing we really want to look at is being able to make these Matplotlib a little bit more useful to us. So essentially what that means is let's add some labels to our axes. Let's add some labels to our charts, and let's add a little bit of a legend as well. So to do that, let's go back to our sign function. So I'm going to go back to my linspace. I'm going to say, all right, I'm going to need numbers from 0 to 2 times pi, np.pi. Because I know I should never reused x, but I did. And I just want 50 of them. We're going to keep this nice and simple. We're going to do our plot.plt.plot x np.sign of x. We're going to make this thing red. And we're going to add a label to this. Sign x. We're going to do a plot, and it's going to be x, and we're going to do np of cosine x. So these are my two arrays. And I'm going to make that thing green with the hat. Oops. Label is going to be cosine x. Oops, I need my tip there. All right, now I'm going to give it a legend. Make it a little bit easier to read. I'm going to give it some labels, plot.xlabel. So we're going to go ahead and give it the x-axis. We're going to just call this rads. And we're going to do plot.ylabel. And just we call that amplitude. And then just so it's nice, we're going to give our graph a title. Sine and cosine waves. And we'll do a plot.show. And we'll run that with Shift Enter. So now we get our cute little graphs all in one. We get a title. We got a legend in there, and our amplitude and our x-axis and our y-axis are labeled. And what's really cool about this, if you click Save, or if you right-click on it, you can do a save image, and you can download that image that you just made as a JPEG, and then you can put that anywhere you need to for your future. All right, so this is kind of a walkthrough on Jupyter, a walkthrough on Python, and a walkthrough with Matplotlib inside of Jupyter. So I'm going to go and give this a name, intro to Matplotlib. And hit OK. So now our guy is going to be all saved and ready to go. And with that, before handing it over to Scott, I was going to see if anybody has any questions that they'd like to ask the panel. You can go ahead and click chat.
Is it possible to install other Python?
Yes, there is. Right now, you do need to fill out a ticket and get with somebody here at TAC, and we will make those options for you. There is an idea of allowing users to customize their Jupyter notebooks and their Jupyter environments, but that's not quite available yet. But it is coming. It is coming. Yes. But if there is a library that you see might be necessary, it would be nice to fill out a ticket, and we'll see if we can get some information on there. To fill out tickets, there is this link over here, the DesignSafe-CI.org/help/tickets. You can go there, fill a ticket out, and one of us will be able to help you out. If you have any questions regarding this training material in particular, or any questions for me, you can email me at training@DesignSafe-CI.org. With that, if there aren't any more questions, I look forward to actually reading your email. Please contact me. And with that, I'd like to hand this over to Scott. Hey, Scott, are you there?
Yeah, we're having a little feedback. Elnaz is here next to me too, so we were just getting an audio problem.
Okay, no problem, Scott. I'm going to go ahead and mute my mic here and turn it over to you.
Okay, so I'm going to make an introduction here of, let me see, let me share my desktop. So I'm going to talk about a Jupyter Notebook that we recently developed in the form of an interactive digital data report. So this is from the UC Davis Centrifuge Facility. We recently completed a project there. I did my PhD there and have done a number of projects there as a professor since then. And when we usually do a data report, the process is to write a static document. So this would be like a Microsoft Word document that we then convert to a PDF file, and we append plots of all of the data quantities that we measured during the experiment. And then we have this static PDF file that people can download, and they can also go and download the data and look at it if they want to. But the Jupyter Notebook provides a really nice way for us to make an interactive data report so that users can plot exactly the data that they want. And so let's see. Charlie, which of these versions should I open? Will they all work okay?
I think you can go with this one.
This one?
Yeah.
All right. Okay, so here's our notebook data report. Let me just run everything so that you can see it. I'm sure that some of you are interested in the code, but probably the end product is better. Let me minimize that so that you guys can see it here. Okay, so this is essentially the same information that we would publish in this sort of static PDF file, but it's rendered here in an HTML format within the Jupyter Notebook. So we're mixing together here HTML and Python code to render this interactive notebook. So this particular project was a soil structure interaction project. We were analyzing culvert structures, and it's funded by Caltrans. And Caltrans was interested in understanding whether their seismic provisions for culverts are adequate. And nobody had ever really done much testing on these structures. So we configured an experiment consisting of 2 culvert structures in dense sand, dry sand. We shook the base of the model, and we were characterizing the response of the culverts. So there are a couple of reasons why I really like this digital data report format over the traditional static data report. In a minute, I'll have Elnaz kind of walk through this, and she can explain the different parts of it. But one of the things that I like about it is that you'll see that we're reading in data directly from a comma-separated value file. So we can set up our channel list, for example, in Excel by opening the CSV file. And then that CSV file is stored in the cloud here with the notebook. And when you open this notebook and look at it, it'll read that CSV file and render a table inside of the notebook. So you don't have to worry about having conflicting versions of the same information, right? Let's say that we realize that we reported the wrong position of a sensor. We only have one place now that we have to go to change it. And once we change it, it'll be rendered in the notebook automatically. We don't have this static document that's in disagreement with our actual data, right? So it avoids the problem of having potential conflicts. Another thing that I really like about it is that users can plot whatever data they want. So at the end of the notebook, you'll see we have a tool available where users can plot any sensor from any motion and click through it. So it saves paper. You know, before we would plot like hundreds of pages of, well, in a PDF file, hundreds of pages of sensor response plots during an earthquake. And then let's see, there was one more thing that I was going to mention, and I can't remember. Yeah, the other thing too is that we've got our drawings now are also interactive. So this is a sketch of one of our square culvert structures. Usually this would just be a static image, right, in a PDF file. But here you can zoom in and interact with it. We have this hosted on an Autodesk server. And there's an interactive feature where, let's say that we forgot to specify the thickness of the culvert, right? We actually do have it here at 0.375 inches. But you can come in here and actually make a measurement in this interactive drawing, and it'll tell you that distance is 0.375 inches. So it's hard sometimes to know exactly what information to put in a sketch that users will be interested in knowing. So by having this sort of interactive drawing available, we know for sure that users can click on whatever information they might be interested in knowing about that drawing, at least any dimension. So Elnaz, do you have it open on your computer, or do you just want to use mine?
I think that I can share my. I think that I can.
Can you share your desktop?
No, I cannot.
Here, why don't you just go through it on my computer?
Sure.
So this is Elnaz. She's the person who actually did all this work. I didn't want to take credit for it. She spent a lot of time learning how to do this.
Thank you very much, Professor, for your introduction, and hello, everyone. So I just want to show a little bit more detail about the report that we have prepared. So what we did actually, the workflow was to write the report in, let's say, LaTeX, which can be easily converted to other formats. So first of all, we wrote our report in LaTeX and then use existing commands like and converters like pandoc or HLaTeX to convert it to the HTML code. So this is kind of the preview of a code we have here. And I just want to go all the way down. So it's a long code, but when you convert it from LaTeX to the HTML, everything is available and you don't need to write everything from scratch. The only thing that we need to do is to edit it a little bit to add the features we are interested in, which was the iframes for our AutoCAD drawings and also the CSV tables that we wanted to show them as a HTML table. So then for doing that, we only added some, let's say, headers to our HTML code of the report, which is that header here, that short header for converting the CSV tables to HTML table. And also, the only changes was for adding the iframes for our AutoCAD drawing, which I'm going to show an example of that. Let me just go a little bit down. If I can find it.
Maybe do a search for iframe.
Yeah, I think that maybe it should be something. Okay, here it is. So here is an example. We get that link from Autodesk. So we use the drive there, and you can get a link from that. It's like doing, like, for example, Google Drive. And then I'm just adding that link to this iframe, and when I compile it, it will appear as a frame of that figure. And at the end, the other thing that we can have is that interactive tool for viewing data. So here is what we add at the very end is this the one that doesn't show?
Oh,
So let me run that to see if I can get that interactive thing at the very end or no.
I think we may need to restart our server. Hey, Charlie, are you online still?
Yeah, Scott, I'm here.
We're not seeing those. We're having the same problem with the widgets not showing up. Do we need to restart the Jupyter server or something to get it to work?
Yeah, try that. Try stopping it and restarting it. I was able to get that working yesterday when I was playing with it. So
let me try another version. If it doesn't work, then we can do that.
you may also try just running that one cell and see if that brings it up.
Okay, so let me do that then.
How do we stop the kernel? Yeah, let's do that.
So let me go to the end of my code and just run the very end cell, which is that interactive thing. Okay,
there we
so
go.
here we have our interactive small tool to viewing data. So here, for example, we wrote another notebook to read the binary files that we got from the centrifuge test and converted that to ASCII files. And here is examples of the shaking events we have. So we can select the events, for example, and after doing that, we can then go through our sensors, which anyone that we would like to see, and see the results very easily next to our digital report, which I think is a nice feature to have.
Can you zoom in on that figure or anything too?
Yeah, I think, so this is the basic one, the basic figure that we are using, and we can have a zooming using the one which is provided by Matplotlib to zoom there as well to see the data. And then we can go back to the previous screen. So I think that you want to add any more detail?
Yeah, I just wanted to show the interactive table too, where
sure.
we have the CSV. We may have to rerun the whole
So
thing.
this is, no,
Here
this
it
is
is.
actually.
Here it is. Okay, so this table right here, this is a list of the sensors that we're using in this particular project, and this is read in from a comma-separated value. So this is not a static HTML table. It's in a little scroll window, so you see the scroll bar over here. We didn't only have like 10 sensors, right? We had a fairly,
Just
reload.
Mm-hmm.
This is the problem with live demos, right? It's always risky. Let me just run them all. Okay. All right, here we are at that table. So you can scroll down and see all of the sensors that we had in here. And again, if we have to change something, we say we recalibrate and realize one of our calibration factors was wrong, or the position of one of the sensors is wrong, or something like that. We don't need to go and remember to change it in a bunch of places, right? The Jupyter Notebook is reading it all from one source. So there's not this data version problem that might otherwise come up. So I think that's it for our demo, Charlie. Should we open it to questions now?
Yeah, let's go ahead and open up to questions. So if anyone has any questions that they wish to contact us with, please do. I'm going to go ahead and go back to sharing my screen. Scott, if you want to exit out of yours.
There you go.
Thanks, man.
So the question in chat is, can they get a copy of the code?
Copy of Scott's code? So soon here, we will be creating a training repository. So all the documents that you see on our training sites, any demo code that we show you on our training sites will be available in that training repository. As soon as that's up, then Scott's Scott has gracefully let us use his notebook you put into our training demo, so other people can use that notebook and see how he did certain items. So you are cool to share that, right, Scott?
Yeah. Our plan is to make it available. So right now, you guys, nobody can access it except for the project team. I think that there are a few things that have to fall into place, like setting up projects on DesignSafe. And once that happens, we'll make it publicly available, and you'll all be able to go and use it online. The online instance of it will be a read-only access, so you can view the data just like we were doing now. But if you wanted to copy it into your own directory and use it as a starting point and just modify parts of it, that would be okay too. And we have other codes that we're also working on that will make available to everybody. One of them will, for example, read binary data that's stored in the centrifuge facilities data format and convert it to ASCII text file, and you can truncate data and do some other processing to it. And we also have one that will apply filters to acceleration data and compute velocity, displacement, and acceleration response spectra. We're still working on that one, but it'll get there. I see a question here too that says how much of our notebook was done as raw HTML and how much was done with some nicer GUI editor. The raw HTML was pretty minor. Elnaz wrote the report in LaTeX and then used a converter to generate the HTML. So we use that converter, and so the HTML looks pretty complicated, but we converted it from LaTeX. If you write in Microsoft Word, you can also save as HTML and paste that. The formatting may not be as nice as you see in Word, but you can paste the HTML into there. So we did write some HTML, but not much.
And if the report is simple, it doesn't have that much, let's say, cross-referencing or something like that, maybe you can even use a Markdown to do that, which is a lightweight language. But for us, LaTeX worked better because we had lots of details that we wanted to include in our digital report.
Can you type in the editor from LaTeX to HTML, just so that it's... I think that's good right there. You still there, Charlie?
We cannot hear it.
Or into the Jupyter Notebook for you, Scott.
Sorry, Charlie, I think you were muted there.
Oh, okay. I'm sorry. I'm back live again. I see a couple questions here. One of them was saying, hey, can you share your code in PDF format since we don't have projects available yet? And the other question somebody asked here was, how difficult was it to do the conversion from LaTeX to HTML in Jupyter? Now, mind you, all the markup, your markup cells, they do take LaTeX naturally. So you can put LaTeX directly in there with the proper tag, and it will convert it for you. Of course, you can also go the HTML route.
Yeah, so we didn't do the LaTeX to HTML conversion in Jupyter. We did it separately using HT-LaTeX. There's another converter, Pandoc, that didn't work as well. And then we pasted it in. Yeah, we could make the code available in PDF format. Charlie, is there a better way to share it? How long will projects be until we have that?
We can put that in our training archive. So the training archive has all the documents, videos, and things like that that are useful. So we might, if you wish to, if you could, then that'd be a fantastic place to put it. We could just put it in our training archive and people can download it from there.
Yeah, it might be better just to make the notebook available in its current format rather than converting to PDF, right?
Yeah, that'd probably be the best idea, is keeping it as a IPNYB, and then we can put that into our training archive. So.
Yeah, we can do that. I mean, we're still working on it, on parts of it, so it's not final yet, but just to see the code structure, you know, I think it's okay to share it that way.
That'd be awesome, Scott. Thank you. Somebody else here asked if the DesignSafe team knows of Jupyter Lab, and yes, we do know of Jupyter Lab, and that is in our wish list of implementation. So. But right now we're using a Jupyter Hub. So are there any other questions? All right. So with that, I'm actually going to go do a little bit of a plug here. So I'd like to just give thanks to people. Ellen Rathje, who's our PI on DesignSafe, Tim Cockrell, Jamie Paget, Scott Brandenburg, thank you so much for sharing. Dan Stanzione, who's our director here at TAC. Steve Mock, who's the director of the ACI group, who put together, his team has put together an incredible interface with the DesignSafe-CI. Matt Hanlon, who was with us here at TAC, who did the brunt of the work. Josue Manuel, who helped me out a lot. Joe Stubbs, who is our Jupyter Hub guru here and container guru. Matt Stelmazik, Hedda, who's our web team leader, and Juni, who's one of our educators here. And anybody else out there I forgot? I'm sorry if I forgot your name. I know Craig, you should be in here as well. Some references and our plug. So we're going to have another webinar in about 2 weeks. We're going to cover Jupyter and R. We're going to do some data analysis and some plotting in R, similar to what we did with Python today. And that's going to be Wednesday, November 9th, 1 p.m. to 3 p.m. Central Standard Time. Once again, feel free to comment. Feel free to email us at training@designsafe-ci.org. If you have any questions or having any issues, feel free to contact us either through email or filling out a ticket or replying to the email that I sent to the team earlier. I really appreciate you guys joining us today. No, 2 hours is quite a bit of time to go through a webinar, but I appreciate your time. And if you haven't, I'm looking forward to hearing from you guys. If there's nothing else, then I think we'll go ahead and close it out. Thanks a lot, guys. Guys, have a great day.